This is a video for AQA Further Pure, First Order Differential Equations, 1.2, General and Particular Solutions. So if we're going to solve a differential equation, we're going to use integration. And each time the integration is used, we get an arbitrary constant. For example, if we've got this, dy by dx is 3x squared plus x, when we integrate, we get x cubed plus a half x squared plus c. This is a first order differential equation. It just has dy by dx. And if we have higher order equations involving second or third derivatives, then the number of constants will be equal to the order of that differential equation. So for this differential equation, this solution is called a general solution. It's a general solution because it has this constant in it, and at this stage we don't have a value for that constant. Let's look at what a graph of a number of these solutions would look like. We get a set of curves. We call them a family of curves. And for different values of c, we'll get a different curve on this graph. Let's look at c and the effect it has. If we look at a pair of these curves, the distance between these two is 1 square, or 0.5, and in fact it's still that down here. The vertical separation is still 1 square, and up here it's still 1 square. So these curves are not parallel. They are in fact always separated by a vertical distance of 0.5, and this family of curves represents c values that are allowed to vary between -2 and 3 in steps of a half. If we know a point on the plane that satisfies this differential equation, then we can fix a particular curve. For instance, if it was this point here, then we'd know it was this curve that was our particular solution. Okay, so here's our differential equation, here's our general solution, and here are what we call a condition for that. So this is a point that satisfies this solution here. So if we plug those in, I'm going to get that 1.2 is equal to 1 plus a half plus c, and that implies that c is minus 0.3. So I get a solution x cubed plus a half x squared minus 0.3, and this is called a particular solution, and it satisfies this condition. If we have more than one constant, then we would need more than one set of conditions to be able to sort out all of the constants. And as you'll see in a later video, the constant of integration isn't always just a plus c. It may affect the general solution in a different way. Okay, there's that rewritten for you. There's our particular solution, and there's just emphasizing that the arbitrary constants will need separate conditions, one for each constant. Okay, so back to the family of curves, and there is our particular solution highlighted in blue going through the point 1, 1.2. The next video is 1.3, separation of variables.